Most of us know Redis as a blazing fast caching solution, but did you know that Redis has a whole lot more to offer? I'm going to show you 5 less known features that Redis has that can boost your applications significantly. Hey everyone, welcome back to the channel. Let's dive in. In many cases, when you use Redis, instead of inserting one big data, you're going to store a lot of small data. Let me show you with an example. Imagine a use case that you want to store a lot of small data into Redis. So the number of transactions are quite high. In this case, we have a risk of slowing down our application. So let's store 10,000 records into Redis and see how slow it is. Say for I To see how long it will take, I need to use time package. And after it's done, I will say okay, now let's see how much time it will take to store 10,000 data in Redis. Okay, less than a second. Not bad. Let's do 100,000. Okay, 9 seconds. Not bad, but what if we have 1 million? This is going to be quite slow, right? So the problem here is, as you can see on the right hand side, for every command that we run, we make a round trip to database. So we send a command, we get the results back, and we do it for the next one. But we can use something called pipeline to speed the process significantly. So let's test it. And after I put everything into this pipeline, I will say execute. Now, if I run this, it will be 0.3 seconds, a significant improvement. What if we do 1 million? 3.8 seconds. Imagine running 1 million without this pipeline. It will probably take 94 seconds or even more. So that will be a nightmare. And as you can see on the left hand side, instead of sending a lot of small commands, we create a big batch and send all the commands together and get the results back. This is going to be much faster. So in your next project, depends on your use case, make a conscious decision on which one fits your need. Imagine you have a website and you want to count the number of unique visitors per each page based on their IP addresses. So let me show you by example. This is a handy function that I copied from somewhere to generate IP addresses from a starting point. So I will say my visitors have IP of 0000, and let's say I have 10 visitors. And if I print, you can see that IP addresses are like this. Now I want to store these IP addresses in Redis. What's the best way to do that? Probably the first thing that comes to mind is using a hash map. So let's do that. As we learned just a few seconds ago, I will use pipeline to speed up the data ingestion. Now I will iterate through IP addresses. I know that I mentioned hash map, but here we don't exactly need a hash map. We just need a lot of keys. We don't need their values. So it's a set. So I will use set. In Redis, to add to a set, I need to use sadd. For the key, let's say post 1, and the value will be IP. Now, if I want to see the count of this visitors, I can just use r.scard post 1. Okay, I mixed it up with Golang, so it should work now. And it's 10. Now let's do the same thing, but this time I will use the HyperLogLog implementation of Redis. Instead of post, I will say s::post to say this is a set. And here, instead of sadd, I will use pfadd. pf is the implementation of HyperLogLog in Redis. And to get the count, we have pfCount. And let's name it pf. Let's run it again. It's 10, just like before. So now with this small number, it's quite accurate. Let's increase the number to 1000. And you can see it starts to deviate. It can go a little bit up or a little bit down, but it's very, very close to the actual number. Okay, let's say 100,000. Again, this one is quite accurate. This one is not that accurate. So you may ask, why should we use something that is not really accurate? So the answer is actually in the memory usage. So let's see the memory usage. I will say memory is r.memory usage, and then I will provide the key, and here I will say print the memory as well. So now if I run it, actually let me do this string. Okay, now if I run it, you can see that for 100,000 records, set will use 5.5 megabytes, whereas HyperLogLog uses only 14 kilobytes. Let's try something else. Let's increase the number to 1 million, and this will be quite interesting. You can see that for 1 million records, we're using 48 megabytes of memory, but in HyperLogLog, we are using only 14 kilobytes. Okay, let's try to bump it up to 2 mil. Okay, notice something interesting? So we doubled the size, but the memory usage stayed exactly the same. So look at this. 14 kilobytes, 14 kilobytes. So this is the exact same number. So no matter how high we go, this is going to stay at the same number. So when the count of your data increases, HyperLogLog becomes exceptionally more efficient. So let's try something else as well. You may ask, what's the difference in their speed? So let's try that. I will decrease that to 1 mil again. Import time package. Okay, here I will say start is time.time. And at the very end, I will say time will be time.time minus start. And this many second it will take. So if I run it for 1 mil again, you can see that with set it took 3.6 seconds, and with HyperLogLog it took 3.4 seconds. So relatively the same number. Now let's increase it to 2 mil again and see the results this time. Okay, you can see that HyperLogLog was slightly faster. It's not that significant, but it was faster. But the important part is the memory usage stayed the same. So last thing on this accuracy, again, you may say, why should we go with this inaccurate number? So imagine something like Instagram. The number of likes are never accurate. You only see something like 21K or 2M. You don't see the exact number. Of course, you can click on the number and it will show you the number, but who cares if it's 1 or 10 or 100 above or below? On the lower numbers, it's quite accurate, but when you bump it up to higher numbers, the accuracy doesn't matter that much. So you can use HyperLogLog to different use cases. One of the most important features of Redis is TTL, or expiry time. You can set a time, and when that time arrives, Redis will delete that key. This is pretty handy because you can use it to create something like a rate limiter or temporary ban solutions. So I'm gonna create something like that now. So imagine that we will ban a user for 5 seconds. Then we check if user is banned. Then after a while, we do that again. We can achieve this with Redis. Let me create a function to ban a user. For banning a user, I probably need some identification, so I will say user ID and some time. I will say second, the default will be 60 seconds. Now I need to specify a key. So key can be, let's say, ban and then user ID. So for user ID number 1, the key will be ban:1. Then let's set a record with that key. So I will say I don't really want to store any value in it because I only care about the key being present or not. Then expiry, which I will say set it to second. Let's start with that. I will say ban user ID 1 for 5 seconds. After that, I want to check whether a user is banned or not. So I need another function. I'll name it check. Again, user ID. Key will be this. r.exist key. So whenever the TTL hits, that specific data will be removed. So until we have that record exists, it means the user is banned. I can just return whether this key exists or not. So let's do this. Now immediately I will check. So I will say print okay, let's wait 6 seconds and do another check. So hopefully on the first check, user should be banned, and on the next, user should be fine. So let's try that. And it works. I can actually improve it like this. Okay, let's run it again. On the first iteration, user should be banned, which is correct. And on the next one, user is allowed. Next cool feature in Redis is working with geolocation. So imagine that you have a data set of different locations with their longitude and latitude and a name. Based on user's location, you want to see every locations in a specific radius. So that's a very common use case. So let's actually do that. So first I need to iterate through all locations and add them into a data set. So the function that I need to use for adding these locations into its proper data set is actually geoadd. So let's do that. Geoadd. First we will say a name, so I will say locations. Then we need to provide a sequence of longitude, latitude, and a name. So just like what we have here, it will be, I believe this is fine. So I will say geo radius in locations. Then I will provide the longitude and latitude. So I'll start with user's location, first longitude, and then latitude. And let's say nearby, and let's print nearby. So actually I need to provide the radius. So let's say 2 and unit, let's say kilometers. So I want to find the locations within 2 kilometers radius of user's location. So this should ideally work, and it works. Let's increase the radius to 3. Works just fine. Another example can be finding distance between 2 specific points. So it will be geo distance. First we need to provide the key, then I need to provide name of 2 points. So let's say checkpoint Charlie and Charlottenburg Palace, and I want it in units kilometers. Let's name it distance and print distance. So if I run it, it will give me 6.3, which is, I think, correct, the distance between checkpoint Charlie and Charlottenburg Palace. And feature number 5 is sorted set. In my opinion, this is a great tool to create something like a leaderboard that you want your data to be sorted. So let's create a quick leaderboard. I'll start by saying I have a list of scores. So I'll create a few more. Okay, imagine this is my data set for my scores. Then I will add all of them to a leaderboard data set. So I will say, and here you need to provide a map of ID to the score. So in my case, it will be score user ID So until this point, I should have a sorted set called leaderboard with all the players' scores in it sorted. So let's get the top players. I can use zrange, which will give everything from the smallest number to the maximum number, or I can just use z reverse range. So z rev range will give me the top players. Name is leaderboard. I will say start from 0 and give me until index 2. So give me 2 top and with a score. So I also want their scores. And print top players. So if I run this, it will give me user with ID 6 has 102, correct. ID 1 has 100 and the next one has 91. So let's get worst players. It will be Z. Again, leaderboard, give me 0 until 2 with score. And give me worst players. Okay, you can see that user with ID 5 has -8 points. Next one is 11 and next one is 40. So it works quite good. And what if we want to see the index of a user based on its user ID? So we can find its rank by Z reverse rank. Then leaderboard. And then, so I want to see user ID 8 has what rank? So it will be rank plus 1 because it will give me index, not the rank. So I should add 1. Okay, it is 7. What if I do user ID 6 to see if it works correctly? And it's the first player. And there you have it. Today we have uncovered some incredible ways to use Redis beyond just caching. Whether it's counting unique visitors, managing temporary ban, or building a leaderboard, Redis proves its power with simplicity and speed. Please share your Redis stories and questions in the comment section. I'll do my best to answer your questions. If you enjoyed this one, take a look at this as well. In that video, I'm gonna show you how you can monitor your Docker containers in Grafana. It's a cool thing. As always, thanks for watching. Until next time.